All right, so we got another video here on for trigonometry, double angle and half angle identities. So if you've watched my previous videos on sum and difference identities, this is going to be similar. The only difference is we're using different formulas. Okay, so this stuff is it's really not that difficult. Okay, you've got to know your formulas. Okay, you've got to know the formulas. All right, so let's take a look at our double angle identities. So we've got sine 2x is 2 sine x cosine x. And then notice here we've got 3 different formulas for cosine, double angle identities for cosine. Now, I'm not going to read them off, but which one do we use? Well, you can use any one you want. It's really going to depend on the information they give you in the problem. Think about it. If they give you cosine 2x, they tell you what that equals. And if it doesn't make sense what I'm saying right now, you'll understand it later on in the video when we're working an example. But if they give you cosine 2x and they ask you to find cosine, well, you're going to use this one right here. If they ask you to find sine, you're going to use this one right here. Okay? And then we've got double angle identity for tangent 2x. All right? So with these identities in mind, and what I would do if I were you, pause the video and write these identities down so you'll have them right there so you can see them as I scroll this up to work the examples. Just write them down so you'll have them. All right, so let's see what we have here. It says find the exact value of sine, cosine, and tangent of 120 degrees by using double angle identities. All right. Now, as far as solving these problems right here, I probably wouldn't use double angle identity to solve this. I would use reference angles, but they're wanting us to use double angle identities so we can get familiar with them and learn how to use them. All right, so I want to find, let's do the first one. I want to find the sine of 120 degrees. All right, so remember, we've got our double angle identity for sine, which is sine 2x is 2 sine x cosine x. All right, so if we're looking at this angle right here, this 120 degrees, I need to rewrite the 120 as an angle measure I know. Okay, so if you're taking a trig class, and I assume you are, if you're watching this video, you're probably not watching it just for fun. You probably heard your trig teacher tell you over and over again that you have to memorize the sine, cosine, and tangent of 30, 45, and 60 degrees. Okay? You've got to know those. 30, 45, and 60 degrees. Also 0, 90, 180, 270, and 360. You got to know the sine, cosine, and tangent of those also. And if they haven't, if you're in a trig class, memorize those. Going to make your life so much easier. All right. So I'm thinking about these angles, 30, 45, 60. Well, think about what we've got. We got 120 degrees. Well, look at that. That is equal to sine of what? 2 times 60 degrees, right? So you see what I have here? This is in the form sine 2x. See, here's my 2, and then that x is 60 degrees. Okay? So let's just come down here below and write the formula. Sine 2x is equal to 2 sine x cosine x. There's our formula. So let's expand this out. Okay. So we get, this is 2 times the sine of, now what's x? Well, in this problem, x is 60 degrees. So that's sine 60 degrees times cosine 60 degrees. And now we've all memorized this, right? The sine of 60 and the cosine of 60. We know what this is. This is 2 times sine of 60 is square root of 3 over 2. Cosine 60 is 1/2. And so let's see what we get. This 2 and this 2 cancel. So look at there, I'm left with square root of 3 over 2. And there's my answer. It's that simple. You've got to memorize the formulas. If you don't, you're never going to be able to do this stuff. All right? Whatever they ask you to find, write the formula down. Okay? Write the formula down and then plug in the information. That's all you're doing. All right, let's look at the next one. Cosine of 120. This is equal to what? Well, big surprise here, right? We're going to rewrite this as what? 2 times 60, just like the other one. We're going to do the same thing for tangent too. Now the only problem is, which formula do we use? Well, guess what? It doesn't matter. It makes no difference which formula you use. All right? We got 3 formulas. You want to use 1, 2, or 3. Pick a number between 1 and 3. All right, let's just say you chose 2. Let's use the second one. Cosine 2x equals 2 cosine squared minus 1. All right, so let's write the formula here. Cosine 2x is equal to 2 cosine squared x minus 1. There's our formula. All right. So let's plug everything in. So this is going to be what? 2 cosine squared of 60 minus 1. Because see, in this problem, x is 60 degrees. All right. And so this is 2 times. Now, what is the cosine? What is the cosine of 60 degrees? 1/2. That's right. So times 1/2. Now, make sure you realize this is squared. So cosine of 60 is 1/2 squared minus 1. So that's 2 times 1/4 minus 1. So 2 times 1/4 is 1/2 minus 1, which is negative 1/2. And there's your answer. All right. How about the next one? Tangent 120. All right. We got a shocker coming up here now, don't we? 2 times 60, right? So I'll just rewrite it, 2 times 60. Now, if we were smart, what would we do? We know tangent is sine over cosine, so we could just put the square root of 3 over 2 divided by negative 1/2 and do it like that. That would be the easy thing to do, the smart thing to do, right? Because you do remember tangent is equal to sine over cosine. But to satisfy the instructions, it says using double angle identities, so let's use the double angle identities. Okay? All right, so let's write the double angle identity for tangent. Well, we've got tangent 2x is equal to 2 tangent x over 1 minus tangent squared x. So there you go. What's x in this problem? 60 degrees. You see that? All right, so let's plug everything in. So that's 2 times tangent of 60 over 1 minus, and that's going to be what? Tangent of 60, or tangent squared 60. Okay? right, so here we go. That's 2 times the tangent of 60. What's the tangent of 60? That's one you've got to memorize. That is square root of 3 over 1 minus, once again, tangent 60 is square root of 3. But look at this, it's squared. So that's square root of 3 squared. And so that's 2 square root of 3 over 1 minus 3, which is 2 square root of 3 over negative 2. And look at that, negative square root of 3. All right. So that's your answer right there. So we found the sine, cosine, and tangent of 120 degrees using double angle identities. Now, would I have done it like this? Probably not. I would have used reference angles. Okay? But you've got to learn how to use these double angle identities. All right? All right. Now, here we go. Half angle identities. Well, guess what? We're doing them the same way as we just did these problems right here. Okay? We're doing them the same way. Just a different formula. That's it. All right. So we've got our half angle identities, sine x over 2, cosine x over 2. Now you can see that the half angle identity for sine and cosine, they're the same with the difference of there's a minus and this is a plus. That's the only difference. So just remember what it is and just know that there's a minus for sine and a plus for cosine. That's what you got to remember there. Okay. Now, and then we've got 3 different identities for tangent. Once again, which one do you use? Whichever one's easiest. Just pick one. They're all going to give you the same answer. Okay? Make it easy on yourself. All right, so here we go. We've got tangent of 15 degrees, and they want us to find the exact value, and of course they want us to use half angle identities. Okay? So I've got to rewrite this. I've got to rewrite this in a way that I know the sine, cosine, or tangent. So I know 30, 45, and 60. Okay, it's going to be similar to how we rewrote it with the double angle. Well, 15, I know 30 divided by 2 is 15. So I can actually write this as tangent of 30 over 2. See? And now it looks like this, the x over 2, where in this case, x is 30 degrees. All right? So which formula do we use? Well, any of them. It doesn't matter. Okay? It doesn't matter which one we use. All right, so I don't know. How about we use tangent x over 2? Okay, let's use that one, I guess. All right, so this is going to be 1 minus cosine 30 degrees over sine 30 degrees. All right, so this is what? 1 minus, and what's the cosine of 30? That's square root of 3 over 2 over sine of 30, which is 1/2. Okay. Uh-oh. We got a problem now, don't we? We got to simplify this thing, don't we? Oh, goodness. Well, you remember this from algebra. That's 1 over 1, isn't it? Got a complex fraction. We remember complex fractions. So what do? I find the common denominator of the 1, the 2, and this 2. So that common denominator is what? 2. So I'm going to multiply each term by the common denominator, which is 2. And so we can see here, the 2's cancel out, these 2's cancel out, and I am left with 2 minus square root of 3 over 1, which is 2 minus square root of 3. There's your answer. Okay. Now, you know what? Just for fun, let's use another identity to do the same thing. So I've got tangent of 30 over 2. Okay, 30 degrees. I'm picking up right here. Okay, and I'm going to use this identity. Okay, let's see what happens. So that's going to be the sine of 30 over 1 plus cosine of 30, which that is going to be what? Sine of 30 is 1/2 over 1 plus cosine of 30, which is square root of 3 over 2. And once again, I'm going to multiply everything by 2. And so that's going to be 1 over 2 plus square root of 3. Because see, this 2 and this 2 cancel, this 2 and this 2 cancel. All right. Now, there was a reason that I chose to use this identity instead of this one. We're going to get the same answer. I'm going to show you that. But learn to think about this a little bit, okay? Make life easy on yourself, okay? Look what I've got now. I've got a big old mess. I've got 1 over 2 plus square root of 3. I've got to rationalize that denominator now. So you remember how to do that? I'm going to multiply numerator and denominator by the conjugate. See that? And so that's going to be 2 minus square root of 3 over, and then remember this is just a plus b times a minus b, which is a squared minus b squared. So that's 2 squared minus square root of 3 squared. So that's 2 minus square root of 3 over 4 minus 3, which is 2 minus square root of 3 over 1, which is 2 minus square root of 3. See that? Same answer, more difficult to do. Okay? Learn to see stuff like that. Okay? Learn to see stuff like that. Now, as far as this one goes, I don't know. I don't know what that would look like. I don't think I'd want to try it. That's why I decided to choose one of these. Okay? And I saw that if I used this one, I knew the sine of 30 was 1/2, so I knew I wouldn't have a radical down here. That's why I chose that one. But when I looked at this one, I knew the cosine of 30 was square root of 3 over 2. Oh, that's giving me a radical down there in the denominator, and I knew eventually I would have to rationalize the denominator like I did here. Okay? So that takes a part in your decision making on which one to use. Okay? Don't overthink this stuff. It's simple. It's straightforward. Okay? All right. Now, how about this one? Sine 75 degrees. Sine of 75 degrees. Well, we got to use half angle identities. That's what the directions told us to do. So let's see. What do I know? Half of what is 75? Well, not 30. Half of 30 is 15. Half of 60 is 30. Half of 45 is 22.5. That's not getting me to 75, is it? But I do know the sine, cosine, and tangent of 30, 45, and 60 degrees, but none of those are working. But I do know that the sine, that 75 degrees is 150 over 2. Okay? But I know I just said we want to try to use 30, 45, 60 degrees, right? So why in the world did I use 150? Okay? Well, it's ideal to have 30, 45, 60, but sometimes that just doesn't work out like that. So what's so special about 150? Well, look at this. If I take 150, and I'll call this 150, this is my reference angle, right? You should know about reference angles by now. So I know my reference angle is what? 180 minus 150, which is 30 degrees. So there's my reference angle, 30 degrees. That's good. That's a good sign there. All right. Remember finding exact values using reference angles? And there you go. See, we can find the exact value of 150 because its reference angle's 30, and we know the sine, cosine, and tangent of 30 degrees. I know I'm saying this a lot, but it's very important that you know those. Okay. All right. So let's look at this. Well, obviously we're going to use this one. There's no decision making there. So let's just go ahead and write down the formula. Sine x over 2 is equal to plus or minus the square root of, and that's going to be what, 1 plus cosine x over 2. Okay, no, that's not right, is it? I don't know why I put plus, it's minus. There we go. So there's our half angle identity for sine. Okay, see, it's minus, not plus. Plus is with cosine, minus is with sine. All right, so this is equal to, all right, now, here's the problem. Here's the problem we have. Well, not really a problem if we know what we're doing. It's got plus or minus in front of that radical. So, which one is it? Which one is it? Well, that is the square root of 1 minus cosine 150 over 2. All right. See, our x here is 150. Why is it plus? 75 degrees is in the first quadrant. Sine is positive in the first quadrant. Right? That's how you determine if it's the plus or minus. You look to see what quadrant the angle is in, not the 150, because we're not finding the sine of 150. We're finding the sine of 75. So you look to see what quadrant it's in, and then you determine is that trig function positive or negative in that quadrant. All right. So now we've got equals the square root of 1 minus cosine of 150. What's the cosine of 150? Okay, you should know how to do this using reference angles. Well, the cosine of 30. Okay, see, we find the cosine of our reference angle. The cosine of our reference angle is square root of 3 over 2. 150, because we're finding the cosine of 150, is in the second quadrant. Cosine is negative in the second quadrant. So cosine of 50 is negative square root of 3 over 2. And then that's all over 2. And this is equal to the square root of 1 plus square root of 3 over 2 over 2. All right. So once again, we have a complex fraction we've got to simplify. You can look at each of these being over 1. So I'm going to multiply each term by the common denominator, which is 2. And so this is going to give me 2 plus square root of 3 over 4. See, the 2's cancel here, and then 2 times 2 is 4. And so that's going to be, look at that, square root of 2 plus square root of 3, square root of 2 plus square root of 3 over the square root of 4, split them up. And so that's square root, and then 2 plus square root of 3 over 2. And there is your answer. All right. So, you know, the algebra gets a little messy, but it's not bad. It's not that bad. Come on now, you're in trig. You know how to do algebra now. All right, so what about this one? In each case, find sine, cosine, and tangent alpha. And they tell us that 2 alpha is between pi and 3 pi over 2. 2 alpha is. Now, what are we looking for? We're looking for sine alpha, cosine alpha, tangent alpha. So, yeah, I mean, it's nice that they give us this right here, but we don't need to know what 2 alpha is between. We need to know what alpha is between, because the angle, we're trying to find the sine, cosine, and tangent of angle alpha. So I'll divide each of these by 2. See that? So that's going to be pi over 2 less than alpha less than 3 pi over 4. So alpha, well, what does this tell us? Well, we know we've got what? 0, pi over 2, pi, 3 pi over 2, and 2 pi. So what this tells us is alpha's in the second quadrant. It's between pi over 2 and 3 pi over 4, which is like around in here somewhere. Okay, it's a little less than pi. All right. So we know alpha's in the second quadrant. That's what we're getting out of this. That's what we're trying to get out of that it's in the second quadrant, alpha is. All right, so pull out the, or get that sheet of paper that you had that tells us how to solve this stuff, okay, with your trig identities. Now, let's think about what they're asking us and what they're giving us. They're giving us cosine 2 alpha. That's what we're given. So if you look at your sheet, and I'm going to scroll up here one time, they give me cosine 2 alpha or cosine 2x, same thing. So I can use any of those. I can use any of those to solve. You see that? All right, so look at this. If I use this one, I can solve for cosine. If I use this one, I can solve for sine. So there you go. So let's go ahead and let's just find sine alpha first. So I'm going to use the formula that says cosine 2 alpha, okay, cosine 2 alpha is equal to 1 minus 2 sine squared alpha. All right, let's plug everything in. Well, what's cosine 2 alpha? It's negative 1/3. So I've got negative 1/3 is equal to 1 minus 2 sine squared alpha. And we know how to solve an equation, don't we? I'm going to subtract 1 to both sides. So I'm going to write the sine squared over here. So I get sine squared alpha is equal to what? Negative 4/3. See that? Whoop, I forgot my 2 there, didn't I? And actually it's negative 2. Let me write that a little better so we can see it. So I get negative 2 sine squared alpha equals negative 4/3. And then I'm going to multiply everything by negative 1/2. So I get sine squared alpha is equal to, what is that? Negative, no, not negative. It's going to equal 2/3. All right, so let's see what we've got here. So I got sine squared alpha is 2/3. So that means sine alpha is equal to negative square root of 2 over square root of 3. And if I rationalize that denominator, that's going to be negative square root of 6 over 3, or sine alpha is positive square root of 6 over 3, right? It's plus or minus this. It's plus or minus the square root of this number. And after I rationalize the denominator, I get square root of 6, negative square root of 6 over 3, square root of 6 over 3. All right, well, which one is it? Well, we determined up here that alpha is in the second quadrant and sine is positive, so we know it's not that one. It is this one. All right. Now we've got to do what? Now we've got to find cosine alpha. Now, the good part about this problem is, let me erase that. The good part about this is it says in each case, okay? In each case, find sine, cosine, and tangent alpha. It doesn't tell us what identities to use, okay? Now, we've got sine, so don't we know that sine squared plus cosine squared equals 1? And I just plug this in for sine. You see that? All right, just plug it in for sine. And then solve for cosine. Now, let me say this. For this problem, we could have done what? Since we were looking for cosine, we could have used cosine 2x. Well, let me write it in terms of alpha, since our angle is in terms of alpha, is equal to 2 cosine squared alpha minus 1. We could use this identity to solve for it, or we could use this one. You see that? It makes no difference. See, I know what sine is, so I just plug it in. All right. So the reason I wrote that down is some of you might have thought of that. Well, if I've got sine, I can just use sine squared plus cosine squared equals 1 and plug it in. And yes, that will give you the correct answer. Okay, that will give you the correct answer. But I'm not going to use that one. But I want you to know it is perfectly fine if you do. Now, let me explain to you why I'm not using it. So, in order to use this identity right here to solve for cosine, I would be plugging this value right here in. Okay? I calculated that value. What if for some reason I calculated it wrong? Okay? What if I made a careless mistake, a stupid mistake, and just didn't do it right? Okay. In other words, if I were rationalizing the denominator, and when I did square root of 2 times square root of 3, for some reason I put square root of 5, I added them instead of multiplied them. You do that sometimes. Well, then this is wrong. So when I plug it into here, I'm going to get it wrong for cosine. So why am I using this one? Well, this value right here is given to me. So I'm putting in given information. I didn't calculate negative 1/3. So that's the one I want to use. I want to plug that into here and then just solve for cosine. So hopefully that makes sense, but at the same time, understanding both ways are right. Okay, both of them are right. So let me just rewrite that. So that's cosine 2 alpha. 2 alpha is equal to 2 cosine squared alpha minus 1. So let's plug it in. So that's negative 1/3 equals 2 cosine squared alpha minus 1. So I'm going to add 1 to both sides. So that is going to give me what? 2/3 is equal to 2 cosine squared alpha. See that? And then let's see what we've got. Then not divide, but multiply everything by half to get rid of that 2. So that's going to give me cosine squared alpha is equal to 1/3. So I get cosine alpha is equal to negative 1 over square root of 3, which rationalized denominator, negative square root of 3 over 3, or cosine alpha is equal to positive square root of 3 over 3. So there you go. And then once again, we got the tough decision to make. Which one is it? Well, alpha's in the second quadrant. Remember, we determined that earlier. So cosine is negative, so it's not that one. It's this one's our answer. All right. Wow, and now we got to find tangent. So tangent alpha, well, let's see. Well, nothing up there is really useful, is it? I mean, we've got this, but we don't know tangent 2x. I mean, I guess we could get it. We know cosine 2x, and then if we find sine 2x, that's just sine over cosine for this, and then good luck figuring out what that is, right? Solving that. So look, just use common sense here. Tangent alpha is what? Sine alpha over cosine alpha. Do we know sine alpha? We sure do. Do we know cosine alpha? Yep. See that? So that is going to be square root of 6 over 3 divided by negative square root of 3 over 3. Now we got to do some little arithmetic. So that's what? Square root of 6 over 3 divided by this, or what? Times the reciprocal, negative 3 over square root of 3. And so the 3's cancel. And then look, this 3 and this 6 can cancel because they're both under the radical. Okay? That's how we know they can cancel. They're both under the radical, so we can cancel them. So let's see what we get. That is going to be negative square root of 2. See, those 3's go out. We're left with square root of 1. Here we're left with square root of 2. And so there's your answer. All right, so hopefully all this is sinking into your brain. I hope it is. All right, it's not difficult. Basically, all you're doing is when they tell you to find something. See, they told us to find this. We're given this. Write the identity down. Write it down. Plug stuff in and solve. That's all you're doing. Oh, wait a minute. Let's see. What are we doing? Sine, cosine, and tangent. Okay, so we're finding sine, cosine, and tangent. And here they give us sine alpha over 2 is equal to 4/5. All right, well, they tell us what alpha over 2 is in between, but since we're finding sine, cosine, and tangent of alpha, we need to know what quadrant alpha's in. So to do that, we can multiply this by 2. So that's going to be pi over 2 less than alpha less than pi. So alpha is between pi over 2 and pi, 0, pi over 2, pi, 3 pi over 2, 2 pi. So once again, we're in the second quadrant. All right, so here we go. Now we're going to use what? Half angle identities. They tell me what the half angle is. You see that? They give me sine alpha over 2. So let's see what we can, let's just go up here. There's no choice to, where am I? Here we are. There's no choice to make. We have to use this one because this is what's given to us, sine of alpha over 2. So we have to use this. There's no decision to make there. So first, let's just write the formula down. So I know that sine of alpha over 2 is equal to plus or minus the square root of 1 minus cosine x over 2. There you go. Now plug everything in. Well, sine alpha over 2 is what? 4/5 equals plus or minus the square root of 1 minus cosine x over 2. I wonder what we're solving for. We're solving for what? Cosine. See that? We're going to solve for cosine. Well, and Let me read. I don't know why I put x. That's cosine alpha. Angles in terms of alpha. All right, so to do this, well, what are we going to do? Well, we're going to square both sides because we got to get rid of this square root here. So I've got 16 over 25 is equal to 1 minus cosine alpha over 2. And then I'm going to multiply everything by 2. And so that's going to give me what? 32 over 25 equals 1 minus cosine alpha. All right, because the 2's cancel here, and 2 times 16 is 32. And then I'm going to subtract 1 to both sides. So that is going to give me cosine alpha. Well, I'm sorry. It's not going to give me cosine alpha. It's going to give me negative cosine alpha. I'll go ahead and write it over here. So negative cosine alpha is equal to, let's see, is going to be, what is that, 7 over 25. I'm going to add those. And then I got to multiply through by negative 1 to get rid of the negative. So cosine alpha is equal to negative 7 over 25. So how about that? There's cosine alpha. And what else they want us to find? Sine and tangent. Well, remember this previous problem when we went to work this problem. I went on and on about you could use sine squared plus cosine squared equals 1, but when I explained why we didn't, well, we need sine. The only thing they give us is sine x over 2. There's nothing else. See, sine x over 2, all I can solve for is cosine. So now I have to use another identity. I'm not going to be able to use my given information. I'm not going to be able to use this to find sine because there's no formula that does it. So for this one, after I find cosine, to find sine, I'm going to have to use sine squared plus cosine squared equals 1. You see what I'm talking about? That's the whole key to this trig stuff. Know your identity so you can just go grab them when you need them. Okay? That's all you're doing. All right, so I've got sine squared plus, and then cosine is negative 7 over 25 squared equals 1. So sine squared alpha plus 49 over, because that's 7 squared, and then over 25 squared, which is 625 equals 1. And then I'm going to subtract 49 over 625 to both sides. So I get sine squared alpha is equal to, let's see, 625 minus 49. That's 576 over 625. And so I get sine alpha equals, and what's the square root of 576? That is 24. That's 24. That is negative 24 over 25, or sine alpha is equal to 24 over 25. Remember, plus or minus, because we square rooted both sides. See, we didn't have to worry about it over here because cosine wasn't squared. You see that? So once again, we know we're in the second quadrant. Sine is positive. And so this is my solution for sine. And now we need to find tangent. And then, of course, we know tangent is sine alpha over cosine alpha. So that's going to be, why did I write a 3? That's going to be 24 over 25 divided by negative 7 over 25. And so that's 24 over 25 times the reciprocal, 25 over 7, Look at there, the 25's cancel. That's negative 24 over 7. And that is your answer for that one. All right. So there you go. You're using, I mean, man, we're using all kinds of identities here, aren't we? You see that? And one thing I do want to point out before we finish up, oh, look at this, we got proving some identities next. I bet you're excited about that. But I do want to point one thing out here is for both of them really. See this tangent 15 degrees, okay? If you're doing double and half angle identities right now, you've already done sum and difference. Tangent can also be written as what? 45 minus 30, right? And use your sum and difference identities too. See, there's a bunch of ways you can do these. We just use half angle because that's what they told us to do. Okay? See, same thing here for 75 degrees. We could have done what? Sine 45 plus 30. You see that? But they told us to use half angle. That's what I'm getting at. Know your identities. So if in the problem, if they don't tell you how to work it, you can do it like you want. Okay? Don't be one of those students that, oh, well, this is what the teacher did, so I got to do this, and this. Learn to think about it. Understand the stuff. Don't memorize it. That's the worst thing you can do is memorize this junk. Well, not junk, but stuff. All right. So let's look at this. We want to prove the identity. All right. So let's do this. Let's write sine 3x. Now, how are we going to do this? Well, let's just think about the identities we have. Okay. Let's think about the identities we have. All right, so first I'm just going to write this as, because see, I don't have any formulas for sine 3x. I mean, well, we got this one, if we can prove it, okay? But I don't know anything about sine 3x. I know stuff about sine 2x, sine x over 2, sine of alpha plus beta, alpha minus beta. I know all that stuff. So what I think I'm going to do here is I'm going to split this up into sine 2x plus x. All right. Now, reach deep back into your brain and pull out those sum and difference identities, okay? You got to remember all this stuff. So, let's expand it out. Remember your formula? That's sine alpha. Remember, this is alpha, this is beta, alpha plus beta. So sine alpha times cosine beta plus cosine alpha sine beta. Okay. Pause the video and go get those identities so you can see, and then start playing it again. All right, so I am trying to get something that looks like this, and the thing I notice is all my angles are x, and down here I've got 2x in some of these angles. So what I think I'm going to do is let's rewrite these using our double angle identity. So you got your double angle identity sitting right there next to you, written on a sheet of paper. So we know sine 2x is equal to 2 sine x cosine x, and then times cosine x. Now, see this, I just rewrote as this, and then times cosine x, and then plus, and then cosine 2x. Well, let's rewrite it like this. Let's write cosine squared x minus sine squared x times sine x. So what I did there is I rewrote cosine 2x as this. All right. Now, typically when we see parentheses like this, what do we normally do? What did you always do in algebra? You distributed, right? Cleared the parentheses. So this is going to do is give us 2 sine x cosine squared x. Where'd you get the cosine squared x? Cosine x times cosine x is cosine squared. Plus, now let's distribute. That's going to be sine x cosine squared x minus sine cubed x. All right. Now look at there. We got common terms. Sine x, sine cosine squared, sine cosine squared, 2 plus 1. That's like doing 2x plus 1x is 3x, right? So that's 3 sine x cosine squared x minus sine cubed x. And then let's see, what do we, all right, so we're trying to make it look like this. Well, look at that. I can factor a sine out. So that's going to be sine x times 3 cosine squared x minus sine squared x. And there it is. There's that. So we proved it. That wasn't bad, was it? And I'm kind of curious to see how many of you are still watching the video right now. We got one problem left to do. Kind of curious to see who's watching it. If you're watching it this late, leave a comment down there saying you're still watching. Alright, so, oh wow, look at this one. Half angle identities. So I'm going to do, alright, so I'm going to take this side, the left-hand side, and see if I can simplify it to the other side. How about that? But I think what I'm going to do first, so we'll have it here and we can look at it real quick. And I'm going to pause the video while I do it, and then I'll start playing it again. Alright, so that's what I want to do. I wanted to write down those half angle identities for tangent so we could see them. Alright. So let's take the left-hand side. We've got tangent of x over 2 plus cotangent of x over 2. Now I need to do something here. Alright. So let's start out by, let's just replace tangent x over 2. Let's replace that with sine x over 1 plus cosine x. Is this the best way to do it? I don't know. Okay, that's the thing about proving identities. Alright, when you're proving identities, you may look at something and say, hey man, that looks good working it that way. And then when you start working it, it's a nightmare. So you erase it and you start all over again. That's what you got to do with identities. Sometimes you may not get it going on the first try. Okay, it might be easier if I put this here instead of this. I don't know. Let's just start with this. Okay, and so this is plus. Oh, I'm sorry. What did I do? That's cotangent. All right. Video's getting too long. My mind's going. All right. So cotangent. Uh-oh. They don't give us anything for cotangent, do they? But what do we know? We know cotangent is the reciprocal of tangent. So I can flip them, right? See that? I can flip them. So, well, since this is 1 plus cosine x, I think I'm going to flip this one so I'll have 1 minus cosine x in the denominator. So for cotangent, I'm going to use the fact that tangent is this. Tangent x over 2 is this. So cotangent x over 2 is the reciprocal of this one. So that's sine x over 1 minus cosine x. All right. And yes, look what we're going to have to do now. We're going to have to get a common denominator. Add these things together. See, I just got one term over here. So let's get our common denominator. So that's 1 plus cosine x times 1 minus cosine x plus, I'm just writing the common denominator down right now. Whoop. And by the way, this is the last example. Okay. All right. So let's see what we've got. This is going to be sine x times, now what do I multiply this denominator to get my common? The 1 minus cosine. And for this one I get sine x times, and This one I got to multiply by 1 plus cosine. And so this is going to give me sine x minus sine x cosine x over common denominator. And I'm going to go ahead and multiply that out. That's 1 minus cosine squared x plus, and all I'm doing is distributing the sign. So that's going to be sine x plus sine x. We can see where it's going now, can't we? Do you see it? Look at that when I combine like terms in the numerator, because remember, we can do that when you have a common denominator. You can add the terms in the numerator and put it all over the common denominator. Well, that worked out good. See, those cancel out. So that's good. So that leaves me with 2 sine x over, now look at this, 1 minus cosine squared is sine squared. Remember that? Because we've got the identity sine squared plus cosine squared equals 1. And if I solve for sine squared, that's 1 minus cosine squared. Okay, you know this if you've watched my video on proving trig identities. Not only do you have to know these identities here, you got to know them solved for different trig functions too. And so this is actually 2 times what? Sine x over sine squared x. Ah, look at that. Well, what are we getting? See, we want cosecant. There's the 2. You see the cosecant? That's 2 over what? 1 over sine x, which is 2 cosecant x. Look at that. And we did it. All right. So you are now really, you're getting really knowledgeable in trig. Okay. Watch the rest of the videos in the playlist. I hope this one helped. Stuff's not bad. Okay. Students always freak out over these sections, over on this chapter on identities. You know what the key to it is? Memorizing the identities. All right. If you don't know them, you can't work the problems. It's that simple. Now, you might have a teacher that's nice enough to give you a formula sheet. That's wonderful. Okay? If you're in my class, you get a formula sheet with some of them on there. Not all of them. You got to memorize some of them. So, just know your formulas. And if you got a mean teacher that don't let you have a formula sheet, just memorize them. Okay? Memorize them. All right, so if you're still watching the video, I appreciate it. Give me a like, share, and subscribe. Check out my other videos. Thanks for watching. I'll see you later.